Bonjour. Is this on? Good? Okay. Bonjour. I want to make sure I said that because that is the extent of the amount of French that I'll use in my presentation this morning, so I'll pre-apologize for that, but thank you, Sebastian, for the introduction. It's great to be here. Thanks, Danielle, for a great opening presentation. I think one of the things that was interesting that he talked about there was the component to our owners. How do we innovate? How do we educate that continuum of the work that we're doing? And that's really the presentation that I've brought today to share with you with some of the work that we're doing at CannonDesign. This idea of streamlining the project turnover process with BIM deliverables. How do we kind of break outside of our traditional boxes, whether we're an architect or engineer or a builder, and look beyond what the use case for that building information model actually is? How do we start to extend that outcome to bring further value to our owners that we're ultimately providing this service for? So that's really the scope of the project that I want to present to you today. And we think about that, what's the additional life cycle? As architects, engineers, builders, we're really part of this building facility for such a small portion of time, but what happens 30 years, 50 years, 100 years down the road while the owner is operating and maintaining, renovating, adding to, demolishing different parts of that building and operating it, which is really the biggest cost impact that we see out there. In the US, the National Institute of Standards and Technologies really released two reports. One, the cost of inadequate interoperability, and the other one was a BIM handover guide. And out of that, we were able to quantify this reoccurring cost impact that owners are being burdened with. 23 cents per square foot per year is that cost of ongoing cost avoidance, mitigation, and delays that can begin to occur throughout the life cycle of that facility. And it's really a compilation of things that happen throughout that plan, design, construct, operate continuum that we're looking at. Inefficiencies in the way as we designers share information and translate data. What inefficiencies are created by the design team not doing a proper coordination effort, waiting for the construction team to do that downstream after the release of our contract documents or tender documents. Having contractual relationships to be able to share information and really have an evolution instead of a stop, pass over the wall, and remodel something. Managing that coordination process more effectively in construction, and then ultimately having a plan for how building data is turned over to a client. So they're not re-entering that information, but they're consuming the information that we're all providing them throughout the design and build process of the facility. For our client that we've been working with at The Ohio State University, they took many of these metrics, key ones that they wanted to identify throughout their process, and came up with a 7.1% cost avoidance based on some of those metrics. For Ohio State, they have a $225 million annual construction budget, so that 7.1% comes out to about $15.9 million of potential cost avoidance through a fully implemented BIM standard. Not to say that they're going to save, we always talk about that as a potential cost avoidance. They're not saying they're going to save $16 million a year, but that's a significant amount of money that they can start to chip away at and start to realize and bring value back to the university and provide more services for the students and the community that surrounds them. So just to give you a little context, we talked about $225 million in annual construction. This is a snapshot of part of the university. Right now they have over 36 million square feet of space that they manage, which includes almost 1,300 buildings across 16,000 acres of campus space. Those are facilities that range from healthcare facilities, athletic facilities, residence halls, academic space, research space, a really diverse portfolio that they're taking on and working with. And when they started this project, it was broken down into three phases. One about how do we understand our existing space, how do we develop and deal with new construction, and then how do we implement these ideas at a much larger scale across this campus? There was a very diverse population that had to understand this internally on campus. And when they embarked on this, they really worked backwards. This idea of starting with the end in mind, which we hear about when we talk about BIM for owners. When we worked with them, we actually built out existing facilities so they could understand how to best utilize those for their operations and maintenance strategies on campus. So once they started to get a foundation of those existing buildings, as we see in the build stage, became about how do they maintain them, and then further downstream, how do they begin to integrate new buildings that were coming in on campus, which we'll talk about. And very directly, the image that you see on the left is really one of how most owners start to manage their facilities in 2D. But being able to develop a process where the university could come in and have their internal team actually work to translate that information into these three-dimensional intelligent building information models created that foundation. And this project really had a goal of expediting the quality and speed of the decision-making process across the university. And this was the foundation of what allowed them to do that. These models are not one on the university side that are equivalent to what we would produce as an architect or an engineer. It's not something that you could build from, and we really talked about it as an as-maintained model. It's representational, it's not buildable, and it's something that we worked very hard to define what is going to support the university's ongoing planning and operational efforts. That was always the goal of that information. If it's in the model, it's accurate, but it's also about how much information is in the model right now. You'll see here we started with architectural elements and any vertical structural elements because the initial foundation for them was tracking space and closing the gap on the accuracy of how many square feet that they had that they were tracking on campus. To date, they've got about 72% of the buildings that they want to have modeled at the start. So right now they have over 227 buildings, 25 million square feet plus of building information models on that campus, which is pretty exciting to look at the scale of that and start to manage and see how that continues to move through for what they're doing. So that initial phase of BIM for existing buildings and setting up that workflow and training and support was really one that was about build and maintain. The real challenge came in when they had to integrate. As they were starting to do this, the design and construction community was understanding that, hey, we understand that you're starting to build these models. We have a project, you have an existing building model for that project. We've created this, is this something that's usable? So everybody wanted to really understand what they were doing and trying to partner. And the university was really excited about this, obviously, saying, yeah, absolutely, share your models with us. We'd love to learn more about what you're doing. And that's where this idea of model chaos comes into play. So if 10 different architects give the university 10 different models, it's very apparent that they are set up 10 completely different ways. And there was no consistency or usability for them to understand of how to consume that into their systems. So that really spawned this idea of creating a BIM standard for them, saying we need to have some structure to define what these teams are going to give to us that somehow matches up with what we're doing internally so we can really consume this information, use it, and repurpose it in a very consistent way. And that's where this idea of the feasibility study came into play. You can start to see some of the numbers here, the references to the different NIST reports. There were 3 projects that the university did a study on and started to apply these metrics. What if we did this differently? What would have been the cost advantages or the time advantages that we would have seen? And that's where we ultimately get the end resultant number here of the 7% and some of that quantification that we talked about earlier. That allowed them to jump forward with putting out an RFP for defining a BIM standard. And it was really, that RFP was one that was really generic in some sense. And our team brought together the idea for them that we're going to work with you to define how projects are executed and how deliverables will be formatted. And it was really those 2 themes that governed everything that we were talking about. And it wasn't a conversation about technology as much as it was one about defining a process that could be repeated and utilized. This was really the effort that we embarked on with the university. The bubbles really start to communicate an idea of how many participants they were. And you can start to see the first really 3 sections here before we began to produce and document a deliverable was really one of fact-finding. It was getting into the university, understanding what their needs were, what their concerns were, what they weren't able to achieve, the gaps that they saw in their design and construction process, and really about us listening as essentially an independent third party to really understand where they were struggling and how these tools and processes could begin to better their outcomes. That allowed us to document a deliverable. We were able to refine it and then work with the university to parallel them and pilot it on a series of projects and have a strategy for continuous improvement so we can continue to evolve that standard moving forward. As we did that, we started this process of following the data. And this very simple graph, as you can see, It almost looks like a Dynamo script or a graph or something like that, but it's actually, tracking a series of redundancies and overlaps of how information is shared. A lot of the questions that we asked about is who is the source of that information? Who's the owner? Who's a borrower? If something changes, is it getting changed in multiple locations? Is it getting changed in one spot? Who's the initial receiver of that information? And this was one of the big challenges that we were looking for BIM to be able to address and start to define a strategy of a single source of truth. Not to say that everything was in the building information model, but it was the foundational component that started to define a strategy for who was using geometry and who was going to use data across campus. These were the top 10 key outcomes that we actually received from the university on what they saw as the biggest values for them in implementing the standard and really setting the goals for what they wanted to achieve moving forward. So really highlighting the big three: how can BIM reduce the total cost of operations and ownership over the life cycle of those facilities? Being able to understand how they can leverage a structured data to streamline the turnover process for the facilities at the end of the day. And really thinking about how does this reframe the context of the contractual obligations to which they're setting forth. This is an entire new process that they need to engage in their building design standards to make sure all of us in the design and construction community are able to meet these expectations and ultimately turn over what they're looking to achieve. So if we go back to that initial snapshot at the beginning of the project, we talked about build, maintain, and integrate. Well, that integrate phase really blows up now, and we start to look at the plan, design, construct, operate continuum, and it becomes much more of a bigger process map that we can start to achieve now. The items in red are really the ones that the university has ownership of. And again, if we relay that back to that bubble, that 3 to 5 year time frame for design and construction, we're really looking at that long-term strategy where it's the 30, 50, 100-year life cycle of that university that's starting to look at how to achieve this. So if you download the BIM Project Delivery Standard, this is the original introduction. Really talks about a key statement of being a reference manual for the design and construction industry to understand what relevant 3D geometry and data need to be included in their deliverables. That is the goal. We talk about what are the BIM use cases that the university defines, how do we outline the key project participants that are going to execute on this, and how do we show a deliverable roadmap. How do we use a BIM execution plan? Level of development is a really key component that we talk about for those deliverables and defining that geometry and data facet. We also talk about this idea of a conformed design intent BIM. The university doesn't tell you what software they want you to use. The standard is very descriptive. This is what we want you to deliver. We want you to use our BIM execution plan to tell us how your team is going to deliver those outcomes so we can all make sure that we're on the same page. And that idea of a conformed design intent BIM is really the ultimate outlet there. That along with the asset data worksheet that hosts the information about the individual components. So we talk about a development strategy and then all the definitions and standard stuff that we have in there. And this is ultimately the BIM project delivery process map. When we start to look at this, there's 4 key milestones. Whoops, went the wrong way. There's actually 4 key milestones that the university has, and you start to see here, we talked about an as-maintained or an archived BIM. The university will deliver that to a project team. They'll do the standards. They have their initial project kickoff. They work their way through what they call a one university review, which is the larger outcome where they finally approve that project, which would be done at the end of a DD phase. And as we move forward, there's a construction document deliverable. The construction team comes in. We talk about the process of sharing information and ultimately turning over that as maintained and archived BIM, which then goes back around and has that continuation life cycle. It's about having that ongoing support and strategy for these models to live well beyond just the creation of tender documents or the turnover of construction. These will live on and continue to be a critical part of the university's planning and strategy in the future years to come. Once we created all this, it wasn't just about handing over a document and saying, here's your BIM standard, make sure you give this to all your teams moving forward. Good luck. It was still one about partnership. That's a big outlet that our client, Joe Porostowski from the university, talks about, this idea of partnership, give and take, challenging one another. What if we did it this way? What would the outcome be? What if we did it this way? Let's get 3 or 4 or 5 ideas on the table and discuss what the best outcome for their particular situation would be. Just because that's what the Ohio State University did on their project doesn't mean it's a perfect fit for somebody else, but it's an idea starter and conversation for other owners to hopefully look at and see that there is really a value, and this is an opportunity for them to innovate and really change the way that they understand how a building information model can be used and how this impacts their project delivery process at a much larger scale moving forward. So we had to educate the internal teams. It wasn't that we turned everybody into a Revit user, but they needed to understand the vocabulary, the impacts of this delivery standard on their day-to-day activities. So the project managers were accountable for making sure that these things were completed on their project. And then they had to make sure that information was translated back to their team so it can be integrated, as we saw in the diagram. It was also about bringing new people on. There was a university model manager that was put in place, and there was a university closeout coordinator. Somebody had to be the funnel point for receiving all of this information that comes in at the completion of all the different projects on campus. On the process side, we talked about paralleling the university on multiple pilot projects. We've released a V2 and V3 of the delivery standard. It's now been in play for just over 2 years. Earlier in February of this year, we released version 3, which was focused on data. How are we using COBie and asset information to turn over and integrate into the university's ongoing systems, which we'll see in a couple slides. We had to update contract language, design standards, RFP, RFQs. We talked about design payment schedules. It was really a much larger overhaul than saying create a building information model, which is a pretty open-ended, ambiguous statement that sometimes we're all seeing in an RFP or an RFQ. Or design team will use BIM, we'll deliver full COBie. What does that really mean? You know, what are the specific elements that are important to that client that we need to turn over and deliver? That's what we want to work to find out and really create a business strategy to partner with those owners moving forward, which is much different than what we're accustomed to doing in the past. And our specifications, we also had to think about the delivery process. So we needed to have a front-end spec that talked about coordination so the GC and CM had an outlet to understand what their obligations were when they receive a set of drawings and specifications that they're going out to bid upon. Technology innovation was also important. Being able to create model checkers, rule checkers for these deliverables so they could automate the review process. And for us on the designer construction end to really be able to say, all right, I know that I missed something in my deliverable. I need to go back and fix it before my final submission back to the client. Looking at other things like BIM middleware to really start to stitch all these things together, which we'll see on the last slide, is another key component for the university to ultimately have this environment where BIM is that source of truth, and there's an opportunity to have a data currency about spatial and asset information on campus. And that's really what we're striving to achieve for the university and their outcomes. So one of the big things that we talk about is how many people have seen a RFP come out that says, we'll deliver BIM and COBie? Nobody has gotten the we'll deliver BIM and COBie? Ivanka, I see you're shaking your head, okay. We see this all the time. How many people have opened up a COBie worksheet and seen the fields and rows and columns and tabs, and you think, oh my gosh, I have to fill out this for every single piece of information? It was important for us, and it was important for the university because they knew that if they said deliver a COBie worksheet, that there'd be some pushback from the community thinking, oh my gosh, I've spent all this time entering all this information. But it was about going in and finding what are the top pieces of data that we need about these building components. And this is really what it whittled down to. Not a significant amount of information that we're trying to track. The design team's responsible for portions of this, and the construction team will be responsible for portions of this. We actually outline when in the design and construction process these items need to be populated. Much of the spatial information is going to come by the 75% construction completion point on a project. They can start using that downstream for scheduling rooms and understanding how that building is going to operate throughout the course of the day and the school year. So that was really key. Another key component was being able to automate that. We talked about technology. Autodesk has the COBie Toolkit extensions. Being able to plug those in, have the parameters already embedded in a model for the design team, mapping the parameters so there isn't really additional effort for them to complete this, and then be able to push it out in an organized manner at the appropriate time on a design project. To further that, one of the things that we did was getting that initial COBie export out, pulling out the design data, but trying to find a more creative way to add the asset information that would come from the builder once that equipment was out on the site, was installed, final decisions were made. So what we actually did was taking that basic COBie worksheet, running a macro on it, and then normalizing it into a simplified format, turning that over for the construction team to say, here's a one-tab worksheet that has whatever the 12 to 15 rows that we're talking about. Use this to complete the information. The university then receives that at the end of the project and then can port that into their multiple CMMS applications that they have. With that diverse end use groups on residence halls, athletics, academics, they all use things a little bit differently because they become their own centers, but they can still take that normalized data and consume it into their systems. What used to take 12 to 18 months can now be done in less than a day by them porting that information over because we've structured how those deliverables are formatted. So there's a really immediate ROI for the university on getting this information in place. So the couple other final outlets that we actually saw with them is how do they begin to integrate BIM into their GIS applications? Traditionally, using Esri ArcGIS, they were only taking in two-dimensional information. Now we have a process for them to be able to consume three-dimensional shape files. So now they have a digital three-dimensional map of that entire 36 million square foot, 16,000 acre campus. We're able to look at how that information feeds into their CAFM applications, being able to understand space. If we take that one simple example, of this auditorium, we can understand information about it at a property level, which campus it's on. We can understand what building it's in. We understand what floor it is. And we understand the unique identifier for that individual space, and all the information in the right is what we can actually track about it. It's not to say the design team or the construction team is responsible for that, but there's an organized strategy to making sure they can fill all that information out, take what they receive from that team, and then continue to move it forward. We're able to also integrate that same methodology for assets. The university has a QR coding system. They also have a robust naming convention for how these assets are documented. Each one of those fields is a concatenation of different variables, and being able to understand in the design phase what the nomenclature is for an element. When it comes out onto the job site, you get the QR code, you organize that back to the documents, you put that on, code it, and now we can start to fill out the rest of the information again on the right, consume that into their applications for operations and maintenance and management of those facilities. This starts to allow them to have much more of a proactive approach as opposed to a reactive approach for managing their systems and replacing components on a facility. The last item that we did was work with the university's Office of Energy and Sustainability. These existing building models, how do we translate those here in this example to a GBXML file, into a eQuest file that can be brought into eQuest as an INP and start to support their larger carbon neutrality initiatives that they have in the coming years. This was a process where to do this building, they might have had two simple boxes. They had a wide box, a top box, and a simple energy model where they just banded with a certain window to wall ratio around it, but now they have more descript geometry. They can create this in much less time as opposed to them manually entering those data for those spaces in that tool. So it's another way for them to repurpose and support their total cost of operations over the life cycle of the building. And lastly, if we go back to that spaghetti map where we followed the data, this is now the environment. This is the ideal future state that the university is beginning to realize. As we can see at the top, there's the implementation of the delivery turnovers, there's model information, and there's data information that comes into the university. The Revit information, which comes down here, so the building information models are all consumed into their GIS applications, their CAFM applications, and their energy. All of the COBie data goes into their different asset management tools, their building automation, life safety information, and then ultimately how do they archive those final deliverables so they can be repurposed at the end of the day for those future projects as they move forward. And lastly, I'm sure these slides will be available, but The BIM Project Delivery Standard and their execution plan are publicly available on their website, so you can download the most current version 3 of that to review how they've set their things up, how the execution plan works, how they're leveraging level of development, and really seeing how all of these larger strategies stitch together. And if you follow it on Twitter, you can follow the Buckeye BIM hashtag, which the university talks about the ongoing initiatives in that project. So thank you for your time.
Est-ce que nous avons des questions pour Brian?
Hi, thanks for the excellent presentation and really good sort of presentation about how BIM for FM and how it can be used for owners. The main question here is, how did you guys, or did you guys try to align with other standards that existed? You mentioned COBE, you mentioned IFC, but as an institution, it had its own standard. Is there any pushback from the design community or the professionals to have these multiplication of different standards in the US? And was there a sort of looking at NBIMs or anything to align with something that existed?
Yeah, I think from a standards perspective, there was understanding that the NBIMs was there. But I think it was more about trying to streamline and focus on them as the end component, knowing that LOD was critical as one standard to be the common language that everybody was speaking. The university said, we want to see that the interior wall partitions evolve to an LOD 300 at the completion of construction documents. That was really the driver that we used in that conversation with them. That was the foundation of the data and geometry component. From a larger interoperability standpoint, IFC is part of a deliverable, but the university, with their existing building work, had standardized on an application for them to design and manage and renovate their facilities of being Revit. So from a standard perspective, that was really the other part of it, was making sure that they had information that they could readily use day one on their future projects. So that integration portal, the back and forth, there wasn't much more beyond that we utilized. I said COBE for the data, LOD for the geometry, and defining that. Those are the two big facets that we wanted to, keep it simple and direct and have a common language for everybody to work for. Other questions? Thank you very much. Oh, thank you.